The word combination artificial intelligence is mentioned so often in modern media that today it's difficult to imagine technology innovation without AI. So let's consider why is it called artificial and why it has become so relevant today. My name is Alexander Goncharov. I'm a founder of CVisionLab, developer of AI tools. So let's start with problems that programmers usually solve. They can be split into large classes. Algorithmic problems, the solution of which can be described by a certain set of actions, and problems that you can't describe as a step of actions. Like, for instance, using the square root, the solution of the square equation can easily be done through a formula. But the interaction of a user with a GUI can also be described through a set of simple rules. For instance, if we want to send a message through a form on the website, that reduces to the verification of several conditions and an action. But there are also problems that are very difficult to describe through a sequence of actions that lead you to a solution. For instance, it's very difficult to formulate a set of rules that would allow you to tell if it's a bona fide email or a spam. Or, for instance, to OCR text on the picture of a document. The problem is that there's a semantic gap in solving such problems. To solve a problem like this, you need to teach the machine to interpret data, for instance, text and pixels, just like humans do. And that requires cognitive capabilities, for instance, the ability to learn examples and generalize the knowledge obtained. So, a picture that can be interpreted by a child for computer is just a set of digits, of numerals. And all these numbers can change. They can change by changing the attitude, the perspective, the lighting, a lot of other things. And between the input data, like this picture of a cat, and the result of analysis, attributing this picture to the class cats, there's a big semantic gaps. Machine learning is one of the more widespread approaches to solve the task. As opposed to classic algorithms, developers only describe a model with a large number of parameters and then select these parameters to arrive at the solution. The first model, that's called perceptrons, based on learning by example, was offered by Frank Rosenblatt in 1957. It was implemented on the Mark I computer, and it could identify ABC letters. 400 pixels per image, comparing to the modern smartphone. Smartphones today have several cameras, each of which supports more than 10 million pixels. So what's there in common between artificial intelligence and natural intelligence? The connection is much deeper than the plain words. Let's consider this connection on the example of computer vision. Data play an important role in machine learning, and a considerable leap ahead happened because of the ImageNet data set. The most popular version of the data set contains 1.2 million images in the learning selection. In more than 1,000 categories. The data set turned out to be good enough to teach machine learning models, covering that semantic gap not only for the 1,000 categories used there, but also for other classes. The data set is used for many other tasks of computer vision. For instance, using the models taught on these networks, you can solve the problem of managing free parking space, detect where the slot has been occupied or is free to use. You can do monitoring in hazardous production facilities to check health and security and safety measures there. More than that, these networks can successfully cope with images got through X-ray. For instance, you can teach the model to successfully identify defects in forging based on X-ray images, and even a model that was taught initially to differentiate cats from dogs can easily cope with more sophisticated tasks. For instance, to identify in CT scans lung pathologies caused by the COVID-19 infection. Just a few years ago, the accuracy of image classification on the ImageNet collection was only about 60%. Today, it's comparable to the accuracy of human classification. AI technologies do not rest unchanged. They keep developing, and this curve shows how accuracy of classification was evolving based on the image collection. You see that year on year it gets closer and closer to 100%, which allows using this model for other tasks. This slide shows how these models have changed. Data is an important but not the only component in the success of machine learning models. Available computing power is also very important. Today, we see the assessment of modern machine learning systems where the y-axis shows accuracy and the x-axis is about the computing power operation in giga operation per second. You see that initial models only gave the accuracy of about 50%, but the next generation model, VCG 16 or 19, they were characterized by a much higher level of complexity and provided a better accuracy. Modern models have become much more compact, became less sensitive of the compute power, and offered quite good results in terms of accuracy. Next thing, how the time needed to train the model changed. A couple of years ago, supercomputer needed more than 10 years ago to teach a model. In the middle of last year, 2 minutes were enough to teach a model. Today, to teach a model based on the ImageNet collection, you only require several seconds. It's all doing a machine learning task not only interesting and in demand, but also quite accessible for mass application. So even your regular laptop could be used to solve important problems from real life. Another interesting factor characterizing the AI methods is about the number of open positions, vacancies. This graph shows the number of hiring announcements or invitations mentioning the words AI or machine learning. So we see that the growth has been considerable in the past few years. The amount of private investment made in AI is also growing exponentially. And finally, this slide shows the results of a McKinsey-led poll or survey to identify the penetration of AI in different areas of human activity. So the deepest penetration now is observed in telecoms, in service, The next ones are product development, marketing, sales, and you can see other areas where the penetration is not large enough today, and there's a lot of potential to implement AI-based solutions there. I would like to wrap up my presentation with a quotation from Andrew, the founder of Baidu and co-founder of Coursera. Just as electricity transformed almost everything 100 years ago, today actually I have a hard time thinking of an industry that I don't think AI will transform in the next several years. It's just like with what happened with electricity. Thank you for your attention. I'll be happy to take your questions. Alexander, thank you. Thanks a lot for an exciting presentation. What do you think? How do you surmise? A strong and reliable communication between artificial and natural intelligence. When are we going to have it? In the next years? So we are talking about the next few years or maybe one decade. What does it depend on? Research in machine learning is closely related to neuroinformatics research. These are two parallel spheres that go hand in hand, and machine learning successes are inspired by neuroinformatics achievements. Implementing the methods that are typical of living organisms. Neuroinformatics, by studying the methods of AI, is trying to apply it in the interpretation of their research, and is also making a lot of progress using machine learning technologies. So it's at the interface between these two industries that the most interesting things emerge. Thank you very much.